So basically, those of you that just came in, happy Wednesday, happy Wednesday. Basically, we are expanding this log, meaning I get a log, right, one log, and I'm going to expand it into many different logs based on the properties. And since we've only learned one property, which is the product property says I have a log of a product. I'm taking the log of a product. And remember, log means what is the exponent of this base that gives me this result. And if you notice, we have two results here that are being multiplied. So when we expand it, when we change the log, we are just getting this result, its own log, and this result, its own log. And we're adding them together because we're adding the logs, because we're adding the exponents. Whenever you have two results, right? 3 to the 7th is a result, 3 to the 4th is a result. Whenever we have two results that are being multiplied, we add the exponents. That's exactly what this rule is saying. It's saying the exact same thing, just in a different way. And so we just look for a product here, and then we, there we go. We separate them into its own. And so if we look here, 5 times x, that's a product, right? That's a product, 5 times x. So I'm going to say log base 2 of the first factor plus the other log base 2 of the second factor. And there you go. Any questions? Any questions? So this is expansion, and we also talked about, well, what if I want to go backwards? What if I have several logs being added together? How do I, and I know that's a horrible sound effect for some of you, like, but how do I like squash them together, right? Condense them. And so you use the rule. Since I'm adding the two logs, that means I'm going to get this result and that result, and they're going to be products of each other. Right? They're going to be the product, and just multiply them together to put here, and then those are the same logs that go right here. That is the product property. Now remember, product property, we add the logs, right? If we have a product here, if we're taking the log of a product, we add the exponents or add the logs. Well, what if I'm taking the log, but of a quotient, right? Of a division problem. What do you do with the exponents then? If I'm dividing two of the same base, what do I do with the exponents? Right? Like, for example, if I was doing this, if I was doing 13 to the 10th over 13 to the 3rd, what do I do? Right? Same base, but I'm dividing now. What do I do to the exponents? Does anyone remember? You subtract them, right? You subtract them because you have 10 up here and 3 down here, so it becomes 13 to the 10 minus 3. You subtract the exponents. So guess what we're going to do? We're going to subtract the logs. Log base b of this result, m, minus log base b of this result, n. We're subtracting the logs, or we're subtracting the exponents. It's the same. This rule, and I know some of you are looking and going, no, it doesn't. Yes, this rule is the same as this rule, even though it doesn't look the same. No, you're right, it doesn't look the same, but it does do the same thing. It is saying the same thing. If I'm taking the log of a result divided by a result, right, I subtract the exponents, or I subtract the logs. Log of the top one minus log of the bottom one. Okay? That make sense? Any questions? Okay, someone said, Mister, let's do one. Let's see what we, okay, so here's one. So here we're going to condense. We're going to condense. So I give you what's being subtracted. So into one log. Okay, so let's do this together. So if we look here, log base 3 of 24 minus log base 3 of 8. Okay, so if you look here, these are the results, right? This is what we're taking the log of. Basically, what exponent of 3 gives me 24 minus what exponent of 3 gives me 8. Well, these are the results, and it's the same log, so I'm going to put them into one log. Log of what? Well, this result, which is 24, divided by this result, which is 8. Okay. And if you stop there, you are completely fine. Mister, you are completely fine. Okay. But it does say right here, simplify if possible. So let's see if we can simplify this. So looking at, then this is part of the reason we use logs. Looking at this, log base 3 of 24, this is asking what exponent of 3 gives me 24? Well, there's not really exponent, like 3 to the first power. Hold on. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. Oh, we just passed over 24, so we don't know the exact number. And then what exponent of 3 gives me 8? Well, 3 to the second power is 9, but that's not 8. So we can't figure out these in our heads. But if we put them together, here's what we can do. 24 divided by 8 is what? 24 divided by 8 is 3. So this is log base 3 of 3, which is asking what exponent of 3 gives me 3. Right? What exponent of 3 gives me an answer of 3? Does anyone know that? It's pretty simple. What exponent of 3? That's what log is asking. Log means what exponent of this base, that's what we call it, a base 3, gives me that answer. And the answer is 1, right? 3 to the first power is 1. Duh. And there you go. So this means 1. So if you know a 1-year-old, that can talk, tell them, instead of when someone asks them, how old are you? They can say, I'm log base 3 of 24 minus log base 3 of 8. That means 1. That means 1. Then you can have a really smart sounding 1-year-old. Man, I wish I was 1 year old again, and I can say that. I'm log base 3 of 24 minus log base 3 of 8. And no one would understand what I'm talking about. You'd walk away. Yeah, that's probably the response that you'd get from most 1 year old. Can you repeat how I got 1? Okay, what does log base 3 of 3 mean? Right? We need to understand what logs mean. What does log mean? Log means what's the exponent of that base that gives me this result? So what exponent of 3 gives me 3? 1. That's it. Or again, if you don't know that, let's say you didn't know that. Let's say you're like, Mister, I don't know that. Okay. Remember, to evaluate logs, you just say, okay, I don't know what this equals. So this equals x. And then I would change this to an exponential. Remember that base to that power, because remember the log equals the power, equals the exponent, equals that result. So 3 to the x equals 3. Well, I don't see an exponent here, mister. Well, there's always a 1. If you don't see an exponent, it's a 1. And so when you have two bases that are the same, you can drop the base. And then this exponent equals that exponent, so x equals 1. So that means this whole thing equals 1. Okay, so if you want to do it the long way, you can just change this to an exponential and solve, right? Set it equal to x, or an unknown variable. Change it to an exponential and solve. All right, you want to try one? No, mister. Sorry, you got to try one. Try number 8. Try this one. Can I tell you really quick that this is 0 without doing anything log? Why is this 0? Why is this automatically 0 without having to do any work? Yeah, don't call a 1-year-old a nerd and walk away. You might hurt their feelings. So why is this 0 right away without doing anything? Yeah, you're subtracting the same thing. Like if I said happy face minus happy face, that's 0. Whenever you're subtracting the same thing from itself, it's 0. But can you show it to me mathematically? Can you show it to me using the quotient property? So I'll give you a minute to show me that we know this is 0. We know that equals 0, but show me using the quotient property. Nerd! Is that what you would yell at the 1-year-old if they answered you like that? All right, so use the quotient property to show that this does equal 0. All right, let's do this. So we're subtracting, so this is going to be the quotient. Why is this not 1? Because they're the same thing. Right? Log base 2 of 15 minus log base 2 of 15. If I have something and I'm subtracting the same exact thing, you always get 0. Right? Happy face minus happy face is 0. Right? So that's why the answer is 0. Okay, but let's see, using the quotient property, if we can prove that it's 0 without just saying same minus same, right? That's just a rule. Same minus same. If these two things are the same and you're subtracting them, it's always equal to 0. That's just a basic math fact. If you're subtracting the same thing, you get 0. So let's see if we can use the quotient property. So this is log base 2, right? Because we are subtracting, so we're going to get this result and put them over each other. So 15 divided by 15. And so now we have log base 2 of what's 15 over 15? That's 1, right? So now here we go. This is where we have to answer the question. What exponent of 2 gives me an answer of 1? Right? What exponent of 2 gives me an answer of 1? 0, right? Anything to the 0 power is 1 because 2 to the 0 power equals 1. Anything to the 0 power equals 1. That was one of our exponent rules that we learned a few months ago, that you learned in 7th grade, that you learned in Algebra 1. Anything to the 0 power is 1, right? Why? There's a big question why. Hold on. I haven't played this in a while.
Tell me why.
Okay. So what's 5 to the first power? Well, actually, we're going to do 2, right? So let's do that. Let's just use 2. What's 2 to the first power? 2, right? But everything's multiplied by 1, right? Everything has a factor of 1. What's 2 to the second power? 2 times 2 times 1, right? What's 2 to the third power? 2 times 2 times 2 times 1, right? What's 2 to the fourth power? 2 times 2 times 2 times 2 times 1, right? Don't worry about the actual answer. Just in terms of what that means. What does 2 to the fourth power mean? It means 2 times 2 times 2 times 2 times 1. 1 is always a factor. What's 2 to the fifth power? 2 times 2 times 2 times 2 times 2 times 1. Right. So if you look at this pattern, if I go in this direction, right, I keep losing a 2, right? I keep losing a 2. So what's 2 to the 0 power? Well, how many 2's do you have? I don't have any 2's, but what do I always have as a factor? 1. Right? See that? See that pattern? 1 is always a factor. And the exponent just tells you how many of this base I have. Right? That exponent just tells me how many of that base I have. So I have 2 2's, I have 3 2's, I have 4 2's, I have 0 2's. But I still have that factor of 1. Anything to the 0 power is 1. Yes, we've said this multiple times, and I know it was a few months ago, and I said this in my 11th period. We were talking about something in geometry. I'm like, yeah, guys, we talked about that since August. And someone told me, Mister, August was years ago. And he was kind of right. If you think about to last August when this year started, it does seem like years ago. So many things have happened since then. So many things. And I hope for my case, things are so much better now than they were in August. August, things were horrible. I was going through a whole lot of stuff. And I know a lot of you were going through a lot of stuff, and things are looking up. Things are a lot better. 2020 is a lot behind us, even though a lot of tragedy happened to all of us. And I hope that it's happening for you too, for you guys too. Right. I cannot believe we're in June already. We're in June of 2021. A lot of that craziness is behind us. Yes, we still have that stuff and have to deal with that stuff in our lives because a lot of us dealt with death and sickness and all that stuff. So that doesn't go away. But a lot of that stuff that isn't happening as much now. So hopefully everyone's okay now. Hopefully everyone's a lot better. Everything's a lot better than it was before. Back in August, which did seem like years ago. If you think back to August and then September, then October, November, December, January, February, March, April, May, and now we're June. Yeah, it does feel like so long. And when we step into campus, and most of you guys are going to be seniors. Hopefully, we'll be into a normal year next year for your senior year. So yeah, it has been crazy. But yes, as I was saying, anything to the 0 power is 1. Anything to the 0 power is 1. So yeah, we did talk about that before, but again, that was a lifetime ago, right? Okay. All right, that is the quotient property. Let's expand. Now here you have some freedom to do some stuff, because if you notice here, that's not a quotient, isn't it? 4 is just a number. But the point is you have hold on, I can pause. So time out. So time in, we're back. So now here's what I can do. I can rename this as log base 8, and then I can change this 4 to whatever I want. I can make any type of fraction I want to help with my needs. So what gives me 4? There's an unlimited amount of things we can do. We can do 48 over 12. That gives me 4. Right? We can do log base 8 of, what's another quotient? 16 divided by 4. Yep. 2 over 2? No, that's not. That's 1, right? Just give me a quotient. Give me a quotient like log base 8 of, give me a quotient. Something that divides, and the answer is 4. 36 and 9, very good. 36 over 9, that works too. So the whole thing about these properties is it gives us a little freedom on how we work with these. So I have log base 8 of 4, but I can change it into multiple ways. So I can move it to I can change it, or I can make an expression based on the quotient property. So for this purple one, I can say log base 8 of the top one, 48, minus log base 8 of the bottom one, which is 12. Right? That's one way we can do it. Or log base 8 of the top one, 16, minus log base 8 of the bottom one, which is 4. There you go. Or the blue one, log base 8 of the top one, 36, minus log base 8 of the bottom one, which is 9. Okay. All right, it is 1:17, so we're going to stop here. Tomorrow we will talk about the power property. What happens when we have a power, another exponent inside the result? Right? What can we do there? Little hint, we can get this exponent and just put it in the front. Okay? That's a little hint. That's a big hint. So far we've done the power property, quotient property. Tomorrow we'll talk about the power property. We've done the product property and the quotient property. And tomorrow we'll talk about the power property. And then we'll put it all together and we'll condense when we have a whole bunch of stuff going on. And we will expand when we have a whole bunch of stuff going on. And then we have this nice graphic organizer, which puts everything together on one page. That'll be your classwork for Friday. And that's pretty much it. Pretty much it for today. So if you have any questions, let me know. Those of you that need to catch up, please turn in your work this week. Send me a message. Me and Mr. Davila are here to help you. Mr. Davila is here to help you with any subject. Any subject. Right? Don't let this year be a waste. Do what you can, pass the class, get your work in, communicate. We're here to help you. And if you heard me, if there's people here and they're your friends, reach out to them and tell them, it's not too late. I know it seems like it's too late. Talk to Pacheco, talk to Mr. Davila. They will help you out.